Problem number 5 tells us to circle all of the prime numbers, underline all of the composite numbers, and put an X through any numbers that are neither prime nor composite. So with a problem that has this many different numbers that we have to deal with, you definitely need to be organized to make sure that you don't mess up the problem just because you weren't able to make sense of your work. So I'm going to try to be very neat about this. So I have the number 1, and I know that 1 is neither prime nor composite because it only has one factor itself. So I'm going to go ahead and I'm going to put an X through the ones that are not prime and they're not composite. So now we move on to the number 2, and I'm going to set up a little T-chart for the number 2, and I'm going to go through the factors. And I know 1 times 2 are factors, and then since the next number on my list would be 2 and I already have it, I can stop because we don't need to write 2 here if we already have it listed. So 2 has exactly 2 factors, 1 and 2. So if the factors of 2 are 1 and 2, then that means that it is a prime number because it only has 2 factors, 1 and itself. So it said to circle the prime numbers. So we're going to go ahead and we're going to circle 2. The next number we have is 11. Make another T-chart, 1 times 11. And then we can just go through, and on our calculator we can do all of the other numbers. So eventually I will see that 11 divided by 2 is not a whole number. 11 divided by 3 is not a whole number. 11 divided by 4 is not a whole number. 11 divided by 5 is not a whole number. 11 divided by 6 is not a whole number. 11 divided by 7 is not a whole number. 11 divided by 8 is not a whole number. And 11 divided by 9 is also not a whole number. So we know that the only factors of 11 are 1 and 11, which is 1 in itself, which means that 11 is a prime number. So let's go on to 27. 27. As usual, we know that 1 times 27 is 27, so we know that those both are factors. So let's go on to 2. I can automatically look at this number and know that 2 is not a factor because it's not an even number. So let's go to 3. So 27 divided by 3. I could use my trick of 2 plus 7 equals 9, and 9 is divisible by 3, or I could just use my calculator. So 27 divided by 3 is 9. Look at that, we just found at least 3 factors, so we don't have to go anymore. 27 is composite, so it says here that we need to underline the composite numbers. Okay, so we need to underline this number, which was 27. Now let's do 37. And we need to do 1 and 37, and then we can use our calculator for the rest. And eventually you'll find out that 37 is indeed a prime number because the numbers 2 through 9 are not factors. So we're going to circle this. Now let's try 41. 41 is the same thing. 41 is only divisible by 1 and 41. So this is also a prime number. Now let's go to the next number, which is 75. I'm going to take my work, and to make it a little bit neater, what I'm going to do is I'm going to fold up my paper so that I can keep track of my next work. So the number that we're on is 75. 75 is definitely 1 times 75, so it definitely has 2 factors. It's not divisible by 2 because it's not an even number. And let's try out 3. 75 divided by 3 is equal to, well, look at that. It's divisible by 25 times 3. So 3 times 25 is 75. So that means we have at least 3 factors. And actually we have more if we were to divide it by 5 and other numbers. So we know that this number is composite because guess what? We just found 4. So it's a composite number. So let's do 87. It's divisible by 1. Not divisible by 2 because it's not an even number. It doesn't end in 2, 4, 6, or 8. So let's try 3. 87 divided by 3 is equal to, look at that, 29. So 87 is divisible by 3. And so we've already found at least 3 factors, so we can stop now and call it composite. So we're going to underline this. And once again, we could have done that rule where we said the digits of the number 8 and 7 are equal to 15, and 15 is divisible by 3, so is 87. Let's go to 93. I'm going to once again take my paper that I folded, and I'm going to turn to a neat space, and I'm going to write 93. 1 times 93 is 93. 2 is not a factor because it's not an even number. So then we can take this once again and say 93 divided by 3 is 31. Once again, we have a number that could trick us because it looks like it's prime, because a lot of people think, oh, all odd numbers are prime, but this number is not prime, it's composite, because it has at least 4 different factors here, and we only need 3 to be composite. Okay, so now let's go on to 97. 1 times 97, and we'll test this one out. I know it's not divisible by 2 because it's not an even number, so let's try 3. Oh, not a factor because it wasn't a whole number, so we're going to do 97 divided by 4. Not a factor. It's not 97 divided by 5. It's not divisible because it doesn't end in a 0 or 5, and all 5s are multiples of 5 end in 0 or 5. So let's go on to 6. 97 divided by 6, not a whole number. 97 divided by 7, not a whole number. 97 divided by 8, not a whole number. Finally, 97 divided by 9, not a whole number, so we can stop there. And we know that it only has 2 factors, one in itself, so therefore 97 is prime.